Hi, my name is Chris Murphy and I'm an Unreal Engine evangelist, and today we're going to be looking at Unreal Engine 5's guided tour. So the purpose of this talk is pretty straightforward. I jump in the engine, I show you the cool stuff, and I do my best to kind of present a reasonably grounded approach to what's working within early access and what's there to start tinkering with, and honestly just provide perspective as to what these things look like when they're actually being used by someone who's spent a little while tinkering with the engine. So without further ado, I guess we'll move on to it. So the first feature I would really like to talk about today is actually not what you would expect. I'm not going to go into Lumen or Nanite just yet. I actually kind of want to start with the new coat of paint. Specifically, I want to go through a couple of the UI changes that I personally find really useful. Now, the first of these things is control space. At any point, if you hit control space, it'll actually open up the content browser. This is really useful because regardless of where you are, whether it's in the main screen or in a material, you can hit control space, access whatever it is you need at that given moment, drag that thing in, and move on with your life. I find this shortcut really, really useful. And again, if I was in the main scene, I could hit control space and just drag in another tree. And we're good. So we can see that that's kind of useful. The other thing I want to point out is that if you are using Unreal Engine 5 on a laptop or a single screen, one thing that I find really, really handy is F10. So F10 will automatically go ahead and dock any of these tabs here and provide you far more screen real estate than you would have otherwise. Again, it's a simple thing, but it just makes life a lot easier when you don't have that much screen real estate and, every centimeter counts on your screen. So F10, as I said, useful little hotkey. Do advise if you are running off of one screen. I'm going to kind of keep it default for the time being. So from here, let's step into Lumen. Lumen is Unreal Engine 5's new fully global dynamic and reflection system designed for next-gen consoles. Now, Lumen is the default global illumination and reflection system in UE5. It renders diffuse interreflection and infinite bounces and indirect specular reflections in large, detailed environments at scales ranging from millimeters to kilometers. So what does that mean? Well, first off, that means it's fully dynamic. So if we look at the scene that I've got here, and I was to move the sun around and put it anywhere, we can see that when I move that sun, the bounce lighting in the scene copes accordingly. And that's really, really useful. This means that you don't have to wait for your traditional issues of, waiting for your lighting to build, or if you're used to the distance field setup that we used to use, then this just gives you a far more accurate result, which again, very, very, very handy. Now, the next thing that it means is, as I said, we get reflections. So if I was to move the screen down to here, you can see that we're actually getting reflections. I'll put the sun in a slightly friendlier spot. You can see that we're actually getting the reflections here coming off of this, and that they're not just in screen space, which is really, really valuable. The next thing that it means that's quite useful is that if we were to go ahead and create a shape, I'm just going to drag a sphere into the world. If I was to get a sphere like this and I was to apply an emissive material, a really, really useful thing that we have is that when I look over here, you'll see that this emissive asset is actually lighting up the scene. And this, again, is just really, really nice because things behave as you expect them to. So if I was to put this here, you can see that we're getting a soft red glow inside the scene that's being captured from this sphere. So very, very handy, big fan. With this in mind, this is usually around the point where a lot of people ask me, they'll be like, so this is all ray tracing then, right? And that's an interesting question to answer because basically you have two things that are kind of pumping into Lumen. You've got your software side and your hardware side. So you can either enable hardware ray tracing, which feeds all of its data into Lumen and then Lumen does its thing. Or alternatively, if you don't have like a 2080 or a 3080 or something like that, you can still go with the software approach, at which point it puts all of its information into Lumen, and again, Lumen does its thing. So what does that actually mean? Well, that means that when I go to a scene like this, right now I'm using ray tracing for that first pass, right? And if I was to go to ray tracing and look at these reflections, I want you to look at these reflections of the tree just down here, okay? I want you to look at these bits just here. So if I was to go to there and I was to disable ray tracing in Lumen, which by the way you can do with just a checkbox, I turn it off. That's it off, and you'll see that the moment I can't see it. So see that? It got a bit denser when I looked away from it, but it's open here. That's because when I can see the object that's being reflected, it's using screen space reflections, which means if I can see it, it's getting reflected. If I can't see it, it falls back on the Lumen scene, okay? But if I have ray tracing enabled, everything is consistently correct the whole way through. But I do want to point out that even when I don't have ray tracing enabled, if I disable it, we still, the lighting will change a little bit, but we still do get a nice soft green that kind of creeps in from this tree bounce and such. So it is still a very good result regardless. But it does mean that you've got a solution that will work between different levels of hardware. It'll just be a slightly higher quality if the hardware supports it. Okay. So useful thing, but let's kind of like start stepping into what it means to kind of use Lumen and how that functions. So the first thing that I want to discuss is the surface cache. So Lumen generates an automatic parameterization of the nearby scene's surfaces called the surface cache. Now it's used to quickly look up lighting at ray hit points. So if I was to go ahead and enable r.lumen.visualize.card placement, set that to 1, this is what we see here. Now I wanted to bring this up because the result that we're seeing here is actually showing us where all of the cards would be placed when we're running Lumen. Okay, so by having this kind of set up in the way that we have, we're able to, these cards are what captures the Lumen properties for each given mesh at different angles. Okay, so by visualizing this, this is usually the first port of call when things break. So if you start opening this up and you start seeing strange squares going through your map in some way or another, it means that your card placement is probably playing funny business. So that's worth checking into. Now I'm going to disable that. Go back to what we had. With that disabled, we're back to like a regular view. The next thing that I kind of wanted to flag here was global tracing versus detail tracing. So if we're going ahead and we're using software ray tracing mode, then you can choose between whether we're sampling the global distance field or individual mesh distance fields. So global distance field means that we're sampling the wider distance field in the scene, which looks like this. Okay, so this is what it would be referencing for a lot of its information. If, on the other hand, we wanted to look at mesh distance fields, it would be looking at this, which you can see is a far more accurate result. However, it is a little bit more expensive. So if we want to see what the difference is in those results as it functions, if I set this to global, I'll disable ray tracing. There we go. So I've got ray tracing disabled, global and detail, global and detail. So we can see some result changes here around the tree especially. If I look back here and I go global, detail. Okay. So I'm going to go back to regular ray tracing mode because it fills me with joy. But with that, I kind of want to just run through a couple of things to be aware of. The first is that Lumen defaults to epic scalability for a 30 FPS budget. Okay, so it's using roughly 8 milliseconds for global illumination and reflections at 1080p on next-gen consoles. So that's the kind of budget that it's aiming for if you're at epic scalability. So in that situation, Lumen relies on Unreal Engine 4's temporal upsampling to kind of hit the 4K output. If you're running at high engine scalability settings, then Lumen targets 60 FPS. Lumen is currently disabled at low and medium scalability levels, so we can switch back to the existing lighting systems. Now, the next thing I want to touch on, maybe a little unexpected, but it's a really big feature that I didn't really see coming myself, and that is Quixel integration. So a while ago, Epic acquired a company called Quixel, and Quixel have people who go throughout the world and they scan things. They scan statues, they scan doors, walls, ruins, rocks, cliffs, everything. And those assets are free to use within Unreal Engine. So what's really cool about this is there's integrated into UE5. So if I right click and I click Add Quixel Content, it loads up Quixel Bridge. And at the time of filming this video, there's 15,905 assets that are available for you to just pull into your project. So let's say I wanted to get a cliff. I could just type in the word cliff, and I could browse through just all of these assets. And these are assets that are all incredibly high quality. And it's not just 3D assets, it's surfaces too. So in this situation, I'm going to go pull down one that I've already grabbed before, which is this Roman statue. I'm just going to select the quality level, so I'm going to tell it that I want to get the highest quality, and I'm going to click Add. And successfully exported assets down below. And if I go into here, I can now see Megascans, 3D assets, Roman statue. And that asset has been pulled in. Now what's cool about this is this asset has actually been pulled in as a sculpt. So if I hit Control Space and I open this up, you may think that the try count is only 2,000 tries. And that's because the version that you see here that it shows the data for is actually the first LOD that's generated. I'll show you what that refers to in just a little bit. It's the scene proxy. But the actual mesh that we're looking at is running Nanite, which means that if I was to show and I was to actually visualize the Nanite side of things, so as to view the number of tries, we're looking at something that's within the millions of try count. Okay, every single one of those colors as I zoom in is another try. So it's incredibly high density. In fact, for an asset like this, what's really cool is, if you want to see the try count, I can go to Edit, and I can temporarily disable Nanite to check it. And we can see here that this was brought in at 4 million tries. So I'm going to re-enable Nanite, since 4 million tries is basically something that can't be done without it. So I'm just going to click Nanite enabled, and you can see that we're now back to where we were before with the 2000 try mesh. So this is showing me the 4 million, but it's actually giving me a proxy, which I'll go into in just a little bit. Now with this mesh in play, we can see that we can get 3D meshes, but the other thing that we can do is we can pull down surfaces. So again, if I was to right click and add Quixel content, I'm just going to grab something I've already downloaded. I could grab something like this dirty brick floor. So I'm going to grab this dirty brick floor and simply click Add. It's exported it successfully. So if I go back to here and I look for surfaces, I can now see that dirty brick floor has been pulled in. And if I was to drag it into the scene, it's now applying it immediately at a pretty high quality level too. In this situation, it's brought in 8K textures. So we can see here that we can immediately see, that we can easily populate our world. We can add stuff without really having to think about it. And this is incredibly useful when you're doing scene blockouts. This is incredibly useful when you're trying to fill in the gaps. And honestly, it's just incredibly useful when you're trying to get something done and you want to focus on the things that matter. And it's worth noting that you can, if you choose to, export to Quixel Mixer instead and then stylize the assets or redress them in there. You're not restricted to just, use the Megascans to UE5 pipeline. But having this set up is really, really valuable. And it actually leads me into the next thing that I'd love to touch on, which is the modeling tools and where they've gotten to with UE5. It's actually quite impressive where the modeling tools have gotten to. At the moment in UE5 Early Access, they're already in a really great spot, but I do want to call out that between UE5 Early Access and 5.0, you'll see even more improvements. Now, with regards to showing these off, let's go ahead and switch to modeling mode. Now, you'll notice that I don't have a modeling mode available up top. So I need to go Edit, Plugins. So I need to enable Modeling Tools Editor Mode. And we're back. Okay, so you'll see that up top, I now have a Modeling Tools Editor Mode. And these tools are pretty useful for kind of blocking stuff out, but they're also really useful for actually going into the nitty gritty and cleaning stuff up too. One of the features that I'd love to kind of touch on today is Path Revolve, just as an easy example for the kind of stuff that I'm liking right now. If I click Path Revolve, I'm able to select anywhere in the scene. So if I go ahead and get this, I'm able to Control Shift and click and it will move this grid to that position. So let's say that we really liked this area, but we wish there was some sort of pillar, for instance. I can use the Path Revolve tool to easily just kind of click things in place. And I could say, hey, you know, I wish I had a thing that went from here up to here, kind of came in a little bit, up to here. Let's give it unnecessary little bits. Cool. Bring that into there. And then let's go all the way up. And I'm going to connect this to here, here, here. We'll eventually come back down and loop into you. Okay. And I can see that, and I can get an idea for what this looks. This looks a bit silly because I think I need to get that and pull that out a little bit. I'm going to get this and kind of pull that out a little bit too. The rest of this is looking pretty good at the moment, just for a really basic pillar, but I kind of feel like these little bits that I added in the middle were a little silly, so I'm gonna just delete that. And that'll do for the minute. This can be my very simple pillar. And I'm gonna click accept. So this has now gone off and it's given me a pillar. And this pillar looks, all right, it's, you know, not exactly incredible, but I can start to do good stuff with it. So what I mean by that is if I wanted to, I could go ahead and I could remesh it, which means I can totally up the triangle count, you know, pretty significantly, which looks pretty good there. So I'm going to up that triangle count, and while I'm at it, I'm going to reproject the UVs. It's worth noting that there is unwrapping and such kind of built in, but for the time being, I'm just going to go to projected UVs, and I'm going to project them as if it was a cylinder, so they're reasonably consistent. Accept. I might go ahead and just put this dirty brick that we saw a moment ago onto it. And with that in mind, I'm going to reproject scale of 4, scale of 2. Great. So we've got something that's kind of being made there. And what's great though is, you know, if I was to go into these things and kind of set that up, I could comfortably then go ahead and displace it too, right? So if I select displace, by default it selects Perl in noise, so that's going to give me something like this, which is honestly kind of cool too, but it's not really what I want here. I'm going to select the texture map, and specifically I'm going to select this one because I could probably use it. There we go. So, oops, sorry, fix, remove the mouse. We can see that's now kind of exporting that and displacing it along here. You know, if I wanted this to be less in your face, I could set this to a displacement value of 5. But it's worth noting this is like all super tried up, right? If I click accept, that looks okay for an asset. That looks okay for an asset. We've got a pretty high trolley count, pretty high poly count. I can see that if I hit F2, we've got an insane try count right now going on though, right? You know, so if I was to click here and view it, it's sitting at 1.2 million tries. So with that as 1.2 million tries, you know, this would generally, if I was to alt drag and I was to clone this a bunch of times. Bad example because I'm running a 3090, I guess, but that's okay. We can do this pretty quick. I can see the frame rate starting to suffer, and we've halved our frame rate now. And I'll drag again, and you know, we're sitting at about 20 FPS. But for an asset like this, if I go to the pillar itself and I open this up, and I just enable nanite, and I click apply. And I go back to here, you can see that we reclaimed about 30-40 FPS there, which is pretty solid. So with that in mind, I'm just going to delete all the others because they're wasteful. You can see that these tools are useful for starting to kind of handle this stuff, but one thing that I really like about these tools is the Boolean tool. So the Boolean tool is quite cool because it allows me to do this. I'm going to go ahead and I'm going to load in an old faithful asset, which is this round table. Every single person in this session that is an Unreal Engine dev is probably very used to this table. What I really like about this is if I was to put this table here, you can see that it's got these sections that go up and through the wall. Do you see that? If I was to select this wall, control click on this asset, and then go to my modeling tools and select Boolean, this will actually subtract the table geometry from the wall. So if I was to pull this back, you can see here that as I pull into that, it's actually carving that out. I'll view it on the other side so you can see it. So that's the interior of the table that's actually getting completely carved out there. Oops. Okay, so as I pull into that, you can actually see it's carving out this geo. And I think that's really, really cool. You know, and like obviously I've used the table here to kind of create something a bit strange. But you know, if I click accept, Lumen catches up, does its thing, fixes the model. But if I click accept and then we, you know, pretty sure we can get the light coming through those cracks a little bit and start to still get some bounce light. This system's really, really useful because you can say, hey, you know, if you have a regular mesh, you can just say, hey, I want a doorway here now and just carve out a doorway, you know, or you could say, hey, I want to have, you know, all my head is thinking about is doorways now. You know, I want to have windows, or I want to carve this out, or I want to recreate Mount Rushmore. You can kind of go ahead and start doing that kind of stuff. And that's really exciting to me because it just gives us a lot more value because we don't need to go back into Max or Maya or Blender to fix things up again and again and again. And I'm super excited by that. So with that in mind, you know, I hope you're kind of seeing some of the value here of what we're doing with these. But I want to point out as well that like if you have meshes that are almost fitting the bill but not quite, I'm just going to keep messing with this table because it just seems like the thing to do. Let's go ahead and get something like this. You can also load up like lattice deformations. So if you kind of generally liked this, but you needed to pull this up because the surface was just going that direction, you can just kind of do that now and set things up. I know I've just created some abstract art with this table, but I hope you can kind of see the value in just having more and more of these tools in here. The warp tool in particular is really useful because you can get something like this environment. Cancel. So if I was to grab something like this asset and I'll just alt drag it across. And if I was to select warp, we can kind of start to create. So I want to twist it, and this is only going to handle so much. So you can see here that as I twist it, it's starting to break because it's pretty low verts. But if I was to remesh it first and then twist it, we'll probably see a good result. So I'm just going to remesh that. And I'm going to go back to warp. There we go. So you can see now that that's starting to kind of give you a crazy result. And you can kind of start to produce some really strange environments. Like in this case, it's a twist, but I could easily do a bend that was specifically bending around to turn this just into a corner piece. If I wanted to bend it around different axes. So that kind of thing I see as really valuable. Just looking forward, because the more we can avoid having to kind of go into our own separate tool sets to kind of get stuff done, the easier this entire workflow becomes. Okay. One of the other things that I just wanted to bring up today that isn't in the early access build is KubeGrid. KubeGrid's a really useful tool for just blocking out space. You can comfortably grab areas, create ramps, hollow things out, create doorways, windows, etc., etc. This is something that we're hoping will be within the 5.0 release. And you can actually go check it out if you pull down main at the moment, but it isn't in the early access build. But because it does represent a bit of a change in workflow, I wanted folks to just get an idea of the fact that we are still working on tools that are great for level design, and the ability to kind of block out space and experiment, and then easily combine that with Lumen to have a nice looking world that feels right and is something that you're able to reasonably easily iterate on. It's something that we have in the pipe. Just one other thing I want to bring up is this tool's going to be really useful, but I'm also super excited to see it tied in with the other tools that we have there. So seeing Quixel assets being used to easily displace these things we've created means that we can really cook up some really nice environments quite quickly. So with that all locked out, I do want to go back to Nanite. So I want to step back into Nanite because I kind of touched on it briefly, but I'd really like to drill down to it a little bit more. For anyone that's unfamiliar with it, Nanite is Unreal Engine 5's new virtualized geometry system, which uses a new internal mesh format and rendering tech to render pixel scale detail and high object counts. It intelligently does work on only the detail that can be perceived and no more. Now, Nanite's data format is also highly compressed, and that supports fine-grained streaming and automatic levels of detail. Now, if I go back to this statue that we saw before, I do want to highlight something, which is the mesh proxy. And that is to say, whenever a platform doesn't support Nanite, it actually falls back on the mesh proxy, which is kind of a lower poly version that we auto-generate under the hood. So if you open this up and I go show, I can click Nanite proxy. And this is the 2000 poly version, whereas this is the 4 million poly version. Right, so we can see a difference in quality here. But this proxy version is also used by things like Lumen to handle it quickly and efficiently. Now, if you want to, you can adjust how many tries this gets generated at, and I just leave it by default. But this is useful to know because you can kind of get the engine to kind of figure out, hey, what should this be at? And this is great when you're doing things like running it on mobile or running it on a previous gen console or something like that. It means you can still have one general pipeline for development of everything. But when it looks good, it looks really good. So I'm going to go ahead and I'm going to assemble a bit of a scene in background just using one of the Nanite clips here. But while I do, I might just discuss how it works. So during import, meshes are analyzed and broken down into hierarchical clusters of triangle groups. And then during rendering, the clusters are swapped on the fly at varying levels of detail based on the camera view, and they connect without cracks to neighboring clusters within the same object. So this you can preview this with various view modes, but I do want to highlight that this means that there are strengths and there are areas where Nanite is not your best option. You want to use a traditional rendering pipeline. So as far as what types of meshes should Nanite be used for, well, Nanite should be enabled generally wherever possible. So any static mesh that has it enabled will typically render faster, and it takes up less memory and disk space because you're not storing the LODs for each of those meshes, right? Now, a mesh is a good candidate for Nanite if it contains tons of triangles, if there's tons of instances of it in the scene, or if it acts as a major occluder of other Nanite geometry. Now, a few caveats that you need to be aware of. So it must be opaque, and it must be fewer than 2 million instances on screen at once. So only instances that are streamed in are counted. Ray tracing features are supported, but rays intersect with the proxy mesh that I showed you earlier. Where possible, avoid aggregate geos, so like hair and grass and that kind of stuff. And as well as that, avoid closely stacked surfaces. So you can track them down with the overdraw view mode. Outside of this, you can preview what is and isn't Nanite by looking at the Nanite scene. So we'll go into that in just a bit, and I'll show you what that. Also, you're going to get better results if you have smoother normals rather than hard edges. But in general, the Nanite system holds up really well. One thing I'd strongly recommend is to consider using detail normal maps instead of a regular baked normal map. You can kind of ditch your regular normal map if your poly count is high enough, and then you can share a detailed normal map instead, which means that you often actually get a pretty substantial saving in terms of your overall file size if you're able to kind of cut out a lot of stuff. So that's really, really useful when you're trying to get performance and storage saving. You can actually use Nanite to pretty great effect if you think about just what having so many polys means. Like, yes, there's more data being used for all the polys, but if you don't need a 4K or an 8K texture to make that hero asset shine, then that's excellent. So you can see I kind of I mean, this was me using 2 rocks to kind of smash out an environment. But one thing I really, really like is just when your geometry is dense enough, you can kind of just blend assets together, and the polys really hide a lot of the seams that you would expect to see in a lot of cases, which is really, really useful when you're kind of kit bashing stuff. As far as the nanite visualization modes go, you can click overview and see them all. You got the primitives, the number of instances, the clusters, triangles, a mask, overdraw, material ID, and material complexity. And you can see if we go up top here that, again, things like this aren't a nanite mesh, so they're not included in the view here. You can actually see in this mask view that red represents non-nanite mesh and green represents nanite mesh. So I'm going to go back to normal mode here. And the next thing I want to focus on is control rig. So control rig and full body IK are 2 incredible features that some folks just aren't aware of yet. And these have both been in UE4, but they came in pretty late, and UE5 has a new full body IK algorithm. So I'm going to highlight it here. I'm just going to enable them both, and I'm going to restart the editor. So control rig and full body IK represents a new direction for animation within the engine. And it's one that I'm super excited about, because check this. If I was to go ahead and look at a mesh that I prepared earlier, which is a tentacle, this tentacle doesn't have any animations at the moment, okay? It's just a tentacle doing its thing. However, if you right click and click create control rig, you can create a control rig for it. And this actually lets me start to set up a rig that I can then use to animate the tentacle. So what I mean by that is this. To begin with, if we want to go ahead and work with this tentacle, we can see it over here on the left-hand side. And what I'm going to do is I'm going to create a control. And this control is going to be at the very end of it. So I'm going to go to my rig, and I'm going to right click. I'm going to create a new control, and I'm going to call this tentacle reach point. Okay. And I'm going to place this up top. Now, with this up top, what I'm going to do from here, when you drag it up, you need to do one very important thing, which is you need to set initial transform from current. This means that when I click off, if I ever recompile, that'll actually stay there. Now, what's really cool is if I wanted to set this up, I could do it in a couple of different ways, but if I want to, I could use this full body IK node. And this lets me say that the root is the root, and I want to add an effector, and the effector is going to go ahead and move tentacle 15, and it's going to move it to whatever is connected here to this transform. So I could get my tentacle reach point, get the control, and I could just connect it here. And you can see here that when I've done that, you've now actually got a nice way to animate this thing. And the cool thing is I can set this up on a more complicated creature, which I'll show you what that looks like in just a little bit. But with this kind of setup, I can see there's one awkward kind of crink going on at the end there that we don't want. What I can do is, instead of saying get the control transform, you can do a project to new parent. This is really great because it basically says, hey, pretend that control was parented to that top bone and use its transforms appropriately. So I'm going to say, hey, how I want to set this up is I want to project tentacle 15 is the child. The old parent is going to be a control, tentacle, control, tentacle. And you can now see that that is correctly pointing. That isn't correctly pointing, but if I rotate it, it's actually going to rotate it accordingly as well. So we've now got ourselves the ability to control this tentacle. But let's say we want to have a control down the bottom to also control the overall direction of the tentacle. Actually, before I go any further, I'm also going to select this widget, and I'm going to make sure it's rendered a little bit bigger. So I'm going to look at the gizmo. Gizmo transform is going to be maybe 20 by 20 by 20. That's too big. 5, 5, 5. Yeah, that's good. And I'm going to make it a thick pyramid that is, oops, sorry. I have to do it on the transform. Actually, I want to kind of face the other way. I think that'd make more sense in my head. And I'm going to pop it there. So now we've got a nice way to kind of visualize where that is when we're kind of fooling around with it. So with that in play, I'm now going to go ahead and I'm going to set up a quick chain to direct this towards another widget that I create. So I'm going to create another one, new control, and we're going to call this tentacle base control. And this is going to be pretty simple. I'm actually going to go ahead and I'm going to set the rotation. Okay. And I want to do this actual part last, so I'm going to connect that at the end. Great. So I'm actually going to go ahead and I want to set the rotation of all the bones before I even begin to bend them down here. But because I'm doing it on all of them, I'm actually going to do a for each loop and run this on every single thing. So I'm going to say, hey, I want a for each, and I'm going to get a list of children. I'm going to get children of tentacle 2. That way we kind of grab it from around here. I'm going to include the parent, make it recursive. And with all of these bones being grabbed, I'm then going to call set rotation. And this base control, I'm going to go ahead and get the control. I want it to be in local space, and I want to set this in local space. And with that set, I now need to grab just the rotation. Oops, sorry, I forgot to connect the bone. Compile, great. So now you can see that this is now able to bend the base of it, while this is able to bend the top part of it. And we can end up with something that's going to be animatable. I'm going to go ahead and hit compile. I'm going to get this control and make it just a little bit bigger so we can see it, what we're about to do. And once again, I want this gizmo to be a thick diamond, just something that we can see where it's pointing, you know. Great. So what we're able to do here is we're now able to go ahead and get this, which I'm just going to drag into the scene. I'm going to make it pretty big so we can see it. And just for the sake of demonstration, I'm going to pop it down here. Great. So with this in the scene, I'm actually able to start animating it, which is really cool. So I can actually go through, I've got auto key enabled, and if I want to, I can grab any of these points. Let's say I wanted to get this, and I wanted to, move this over to here. So pull this up, and I'm just going to do that, and I'm going to add that as a keyframe. I'm then going to add this as a keyframe at the end, so we eventually loop back to it. But let's grab this and let's grab that and rotate around this way. And we've now got that kind of doing its thing. And when we get to here, it's obviously not quite what we want. So maybe I'll pull that down and go to there instead. Great. We have now a very wiggly tentacle. Game dev is weird. Great. Bit of wigs. Okay, put it down. And, alright, very tentacly tentacle. Great. And if I set this to, I might do the base controls as well, just to make sure this is good. So I'm going to add, and I'm going to add, but as we come out this way, maybe I want my base control to push it just a little bit that way. Could be too much, I guess we'll see. And let's pull you back this way as well. In true animation style, I've kind of broken it a little bit, but that's okay. We pop that in the middle, so we just get a slow move. So now I have this, just a very simple little animation, but you hit save, and this is the really cool part, is you can right click and you can actually go create linked animation sequence. So by creating a linked animation sequence, which I'm just going to save to there, this actually goes off. I'm going to call this tentacle idle. Okay. And what that has gone ahead and done is this. If I close this and we're back to our just unassuming tentacle that we saw a moment ago, this now lets me say, hey, I want you to use an animation asset, and it's actually created an animation which I can now pop out here and have as my island tentacle. That's a normal thing on game dev. Great. So I'm putting that there. If you ever want these to process in editor, by the way, you can say date animation in editor. So we now have our tentacle island. Of course, this was just a quick mock-up of what you can do. If you want to see something that's like an actual robust setup, I strongly recommend you go ahead and check out the ASC Toothison creature by Aaron Sims Creative available in the marketplace. This creature is fantastic, and it's completely set up within Control Rig. So you can actually play back something in Sequencer, and you can then go ahead and open up the Control Rig and just see how it's been set up, and you can tweak with it as you like. This is really great for new developers who are looking to better understand just how Control Rig should be used, and which kind of widgets should be tied to which kind of things, how constraints can be set up, etc., etc. So I hope that some of you go ahead and check that one out. I personally think it's really, really wonderful to have this kind of thing, built into the engine now. Having this kind of thing as something that you can just pick up and modify and tweak without having to, go to your animator and say, hey, I moved the button 10 centimeters above the previous one. Can we tweak that? Having that all in the same space is incredible. And I'm really, really looking forward to folks taking advantage of that. So the last little feature I'm going to touch on is meta sounds. Meta sounds is really exciting to me. And a lot of folks don't know about it because it's hard to screenshot. But if you enable meta sounds in your build, you can start working with procedural audio. This is really, really exciting. It's the new high-performance audio system that's coming into Unreal Engine 5. I'm just going to save the map and restart the editor. Meta sounds is superb because it lets you actually start approaching your sound creation almost more like a technical artist. It actually makes sound creation closer to the material editor in Unreal Engine than to anything else. Like, think of audio shaders when you're thinking of it. To give an example of something really simple, I'm going to create a wind meta sound, which I'll open up here. So to do this is actually really straightforward. If I want to, I could have low frequency oscillation that is going to give me, I'm going to say a frequency of 0.1, so it's going gradually up, back and forth, back and forth. I want it to be a sine wave, and I'm going to get between 800, maybe 1,000 in its frequency. And if I get something like this, and I run a noise generator. So take a listen to the noise generator by itself. Just static, right? It's not great. But if we get that static and we run a low pass filter through it, then we can use this frequency to kind of start to get something. If I run that through a state variable filter, we're able to connect this through. I'm going to run a separate LFO over the top of it, which is going to go 0.22. And I'm going to make this one go through 500 to 950. We now kind of end up with a wind sound that's just being generated through this. And I know this was a really, really basic thing to go through. But if you check out my meta sounds from miniguns to music video that is currently on the Unreal Engine channel, that'll show you how to create procedural music It'll show you how to create like a minigun system that is being controlled through the Metasound. So Metasounds are gradually heating up the barrel, and therefore we're like spinning it around in a different way. So you raising the pitch, you can control it with the number of shots being fired with BPM and stuff like that. It's a really exciting system, and I strongly recommend you check out that video. Unfortunately, due to time constraints today, we don't have time to really step into the procedural music. So unfortunately, Metasounds didn't quite get as much of a spotlight as I would have liked. But I hope today's session has been useful for folks. I'm gonna do my best to answer anything that's in this Q&A. So if you have any questions, just let us know. And once again, I really want to reiterate that the version of UE5 that I've been showing off is the early access build, and 5.0 is still in development. It's coming along, but it means that there's just going to be cooler stuff again and again. So it's really something to be excited about. The early access build got Lumen and Nanite into everyone's hands early so they could start sussing out the pipeline. But I'm super excited to see what folks do with it when this is really fully out in the wild. But yeah, I hope this has been useful. This has been a Unreal Engine 5 guided tour. Thank you very much for your time.